When snow falls, we expect it to melt. The ducks expect the snow to melt too. But what if the snow survived the summer? Even a few inches squeezed the ice under the next winter's snow would give you a foot in a few years and 1,000 feet in a few thousand years, and you'd have a glacier. A glacier is ice that flows. Here's a National Park Service time-lapse of a glaciers flowing down Mount Rainier. It's pretty cool. Suppose you make a pile, like my dear wife Cindy making pancakes. All piles tend to spread under their own weight because the pressure under the pile is higher than the pressure outside the pile, giving a push. We met these physics earlier when one talked about how Death Valley and Nevada are spreading. When it gets stronger, the pile doesn't spread as fast, like most buildings and a cooked pancake. If you hold the pile back, it doesn't spread as fast. Early Gothic cathedral builders didn't make the building strong enough to avoid spreading, and they had to invent the flying buttress to push back so that their masterpieces didn't spread and fall apart. If you pour the pancake batter on something rougher or bumpier, like a waffle iron, it doesn't spread as fast. And it looks cool. Maybe you can imagine one of these flows as the ice that carved Yosemite Valley or deposited Cape Cod. Or Mendenhall Glacier in Alaska. This is the Juneau ice fields outside the city of Juneau. The airport is down there in the lower left. Snow is accumulated on the cold mountains and made a pile that spreads across this waffle iron, making glaciers such as Mendenhall Glacier, which you see here. Up on top on the Juneau ice field, it looks like this, with Penn Staters Kaya Riverman and Don Voigt teaching about glaciers. And Greenland and Antarctica are just ginormous piles of old snow, squeezed to ice, and spreading under their own weight. Researchers working with NASA measured the flow of Antarctica's ice using satellites, and then they color-coded it, with the magenta going fastest and the orange slowest, so you can see the pile spreading under its own weight and funneling into the low troughs of the bedrock waffle iron down 2 miles underneath the ice. It's pretty cool. Sometimes you'll have a glacier on just one side of the mountain because the other side is too sunny or too windy or too steep to keep the snow. But that ice will still be flowing down the mountain the way glaciers do. If the climate warms and the glacier doesn't get as far down the mountain before all the ice melts, it still flows down the mountain away from the center of the pile. So if you look at this Landsat NASA view of Mendenhall Glacier from 1984, the ice flowed down the mountain and it ended here. Go back in 2023, the front of the ice had retreated from where it ended before because the climate warmed, but the ice was still flowing down the mountain, spreading away from the pile up on top. So now you know how glaciers flow, and maybe you'll have pancakes for breakfast tomorrow.